The title of my final instructional design project is Geometry and Design. Geometry students in general need to see not only that geometry is practical, but that problems are often ill-defined. The problems they see in their textbook are often clearly defined with one right answer, and in the real world, problems are often ill-defined and messy, and there is often more than one right solution to a problem. The learners for this project are geometry students in 9th and 10th grades, and they are not honors track geometry students. The objectives for this design are: working collaboratively, students will design a structure that meets given specifications and constraints, and as a group, students will defend the choice of their design to the class. The ID models that I used were Pebble in the Pond, which was embedded within the Assure model. The Assure model has 6 steps: analyze learners, state standards and objectives, select strategies, technology, media, and materials, utilize technology, media, and materials, require learner participation, and evaluate and revise. The 3 steps shown in orange were actually done with the Pebble in the Pond approach, and they were not done linearly but in a cyclical manner. The Pebble in the Pond approach involves the learner working through a progression of problems to develop the ability to solve a central problem. So what I started with was the central problem, and then created a progression of increasingly complex problems. As I looked at those problems, I analyzed what knowledge and skills were needed to solve those problems, and that is what helped me define my instructional strategies and design the appropriate learning interface. The instructional technologies that I used were, of course, the increasingly complex problems, also hands-on model building with physical objects. I also used pencil and paper design on grid paper, and a website to organize and store student products and information. Students will also use different presentation tools of their choice when they defend their choice of a project to the class. The learning outcomes that I anticipate include not only the final learning outcome, but also intermediate skills that would be developed during the process. Students would be able to calculate the cost of materials for a structure. Students will also be able to design a shape with a given perimeter that maximizes the area within the shape, and students, of course, would be able to design a structure. They'd consider cost and area and aesthetics, and they would be able to draw the structure to scale on grid paper. To evaluate this project, I'll use a peer review and also a small focus group of advanced students who have already taken geometry. Also, the first geometry class through the project will provide an evaluation of the project. These will be formative evaluations, and I would intend to improve the project each time. In conclusion, students who believe that mathematics is applicable in their lives will be more interested in learning. And I hope that this project and these problems will help students see that math is applicable in their lives. Also, students who understand that their perspectives and knowledge are valuable in problem solving will become empowered in their learning. There are no right answers to the problems that are given. There are appropriate answers, and all of the students' different skills and abilities and interests will factor into the choice of their solution and their design. So they will be able to see that their perspectives and knowledge are valuable in the problem-solving process.